Yeah, hello. Hansini, are you there?
Yes, ma'am.
Yeah, just a minute.
Yes.
Chapter number 10, right? Yeah.
Yes.
Fine. Hello.
Yes.
Yeah, Hansini's class I have started, ma'am, just now. Okay, okay. She had already joined, ma'am. Okay, I yeah, am I audible, beta? Hello, am I audible? Hello, Hansini. Hello. Hansini, are you there? I cannot hear you at all. Hansini, hello. जीनत, आगे वो बंद करना जीनत तेरा टीवी।
Good evening, ma'am. Ma'am, you're on mute.
Am I audible now?
Yes, ma'am. Actually, there was a network issue. That's why I disconnected.
Yeah, I thought that only because of the network only you might have log out.
Yeah.
Yeah. So I'll just share the content with you. Yeah. What happened? I'm not able to share out. Already I'm sharing, I guess.
Yes, ma'am. It was already shared.
Now it's visible. It was visible to you, but then wasn't to me.
Yeah.
So we are going to see the preparation of alkyl halide by using the phosphorus halide. Okay. In this case, what they said, an alkyl halide may be prepared by the action of phosphorus halide on alcohol. Same substrate, alcohol only. But then here reagent has been changed. Here we are going to use what? Phosphorus halide. So
Okay.
phosphorus halide would be what? PCl3, PCl5, etc.
Oh, okay.
So phosphorus, yeah, Cl or Br or iodine like that. Means like halogen. Phosphorus tribromide, PBr3, and triiodide are usually generated in C2. Means phosphorus tribromide, PBr3, and Pi3. These two reagents generally generated in C2 means in reaction. During the reaction, these reagents would be produced. Okay, see here they have written, see meaning of C2. Produce in the reaction mixture. Correct?
Okay.
Yeah. By the action of red phosphorus on bromine and iodine respectively. How they would prepare? When red phosphorus is like reacted with the bromine and the iodine, you will get PBr3 and Pi3. Phosphorus pentachloride react with alcohol to give alkyl chloride. Phosphorus pentachloride, PCl5.
PCL.
Okay. So examples are given. These are the general thing. Now, what happened exactly in this case? This reaction is given below. When ethyl alcohol, CH3CH2OH, is treated with the sodium or potassium iodide, NaI or potassium iodide means what? Ki.
Yes, ma'am.
Either NaI or Ki. Right. In a
Ma'am, why is HI produced?
Sorry?
Ma'am, it's written that HI is generated in the...
In a C2 here.
Okay.
This sodium iodide and H3PO4 would react with each other to hydrogen from the phosphoric acid and iodine from the sodium iodide would be react to form a HI. And another side product would be formed that would be the phosphoric acid or the sodium phosphate.
Okay.
Okay. So that is none of our concern. Our concern is what? This halogen acid.
Yes.
HX. Okay. Now, what happened in this case? Ethyl alcohol is there, and this OH should be replaced with iodine. And this HI should be prepared in a C2, how we have prepared in earlier NaBr and NH4Cl would be reacted together, isn't it?
Yes,
in the same manner, it happens. Now, what happened? OH would be replaced by I, and this OH and H would be formed water molecule. Exactly same reaction. Only just reagent would be changed. Okay. So what they said, sometimes during replacement of OH by X, alcohol tend to undergo rearrangement. Alcohol will undergo rearrangement. How it will be, I'll let you know. Okay. This tendency can be minimized by use of phosphorus halide. If you use a phosphorus halide, rearrangement of alcohol would stop. Okay. Straight chain primary alcohol react with phosphorus trihalide to give unarranged alkyl halide. For example, I'll let you. Suppose there is a secondary position, alcohol is there. A primary only, suppose here CH3, CH2, CH, suppose CH3, and here CH3, CH2OH, I'm sorry. It will be CH2OH. Okay.
Yes.
This is your primary alkyl halide, right? This is a carbon which attached to only one carbon. So this would be primary, correct? So what happened in this case when this OH would be replaced? with the halogen. Before going, this OH release and it will generate the carbocation, correct?
Yes.
You will get CH3, CH2, CH, CH3, and here it is what? CH2 with positive charge, correct? By the loss of OH. One bond is gone, no, with electron, right? So this carbon would be with loss of valency, that there would be the positive charge. Now what happened? This carbocation is unstable because it is primary, right? So this CH3 group will be shifted from here and it goes at this positive charge, right? So positive charge would be generated on this carbon. You will get like this: CH3, CH2, CH, CH2, this shifted CH3, okay? And your positive charge would be generated at this carbon. And whatever bromine is there, that bromine will be, or bromine or iodine, whatever halogen, it will be attached over here. So you will get secondary halide as a product. जीनत, अगर तू यहाँ बजाते बैठेगी तो मैं क्लास कैसा लियूं? वहां क्या प्रॉब्लम है तुझे? Yeah, Hansini, what happens? Still you're facing network issues?
Yes, ma'am. Now it will
Better
be
you
fine.
not turn on your video, okay?
Okay, ma'am. Yeah.
Not to turn on, it's fine. Okay, are you understand how rearrangement happens, or I need to show it again?
No, ma'am. Can you please show it again?
Yeah, fine. Wait a minute. I told you what, like suppose there would be this kind of structure: CH3, CH, CH3, CH2OH. This is alcohol. It's a primary alcohol, correct? Means this carbon is attached to only one carbon, hence it is primary, correct?
Yes, ma'am.
When this OH would
Yeah.
be released or leave from the compound, it will generate carbonyl carbon CH3, CH, CH2 with positive charge, and this CH3 would be here. Now, what this CH3 does, primary carbocation is not stable. Because of that, this CH3 would be shifted and it create a secondary carbocation. Means it undergo what? Rearrangement, correct? Yeah.
So the CH3 goes up in the
This
chain.
CH3 goes at the primary place, and this carbocation generated, that will be 1 and 2 carbon. This carbon is attached to 2 carbon, 1 and 2, and hence it will be secondary. Correct?
Okay, got it. Yes.
Fine. So at the secondary carbon, when your halogen would be attached, you will get secondary halide. Right?
Yes, yes, ma'am.
Yeah.
Ma'am, so carbocation
Yes.
is not stable.
Yeah, primary carbocation is not stable. It is least stable than that of secondary. Secondary carbocation is least stable than that of the tertiary. Okay.
Okay.
IITs, so that's why I'll explain you. You want to know that?
Yes, ma'am.
Okay, just a minute. Let me finish with this, okay? So what happened? This secondary halide is primary and the secondary halide has been formed. This is a rearranged product, which we are not expected, right? And to avoid these
Yes.
all things, to prevent all these things, what you're supposed to do, you have to use a phosphorus halide as a halogenating reagent. Okay, here it is given, see. The straight chain primary alcohol react with phosphorus trihalide to give a unarranged alkyl halides. This point is important. Please note down. Once you have done, let me know, so I can explain you about the carbocation stability.
Yeah.
Done?
Yes, ma'am.
Yeah. Now see what exactly I wanted to tell you about the primary and secondary. Suppose this is your primary carbocation. Here two hydrogens, okay, CH2 with positive charge, and it may attach to one of the CH3, okay. So primary one, correct? Yeah. So in this case, only one CH3. This CH3 group have a inductive effect. Electron
Okay.
donating inductive effect, okay. Okay. And even these hydrogens are there. These hydrogens are in hyperconjugation. How it will be, I'll let you know. Hydrogen, hydrogen. This hydrogen, okay. And here carbon, 1, 2, 3 hydrogens, okay. Correct? Same
Yes, ma'am.
structure. Here is a positive charge. Now what happened? This bond in between carbon and hydrogen would be utilized to stabilize this carbocation, and you will get hyperconjugated structure in this way. Here hydrogen, CH2 doubly bonded with this. Okay, positive charge would be nullified and hydrogen would be here in a close proximity. Okay, fine.
Yes, ma'am.
So like that, how many hydrogens are available in this structure? Just 3.
3.
Okay, that is CS3. But then if you go to secondary carbon, one more CS3 would be there.
Yeah.
Correct? So in this case, how many hydrogen would be available for hypoconjugation? 6.
6.
And if you go to the tertiary, there would be one more CH3. Correct? So there would be
Yeah.
9 hydrogens are available in the hyperconjugation effect. And due to this electron donating inductive effect of carbon and hyperconjugation effect of hydrogen, which is maximum in tertiary carbocation is more stable as compared to secondary. Secondary is more stable as compared to primary. Clear?
Oh,
Understood or not, beta?
yes, ma'am.
Hello.
Understood.
Fine. Now see, I hope you have written this.
Yes.
Fine. Now see the next thing, by using the thionyl chloride. It is the important reaction, okay? This
Ma'am, this
reaction,
is the,
you're not audible, beta. Hello?
ma'am, this is the method, right?
I am not able to hear you at all. Hansini? Hello?
Ma'am, now am I audible?
Yes, yes. Thionyl chloride is SOCl2.
Ma'am, this is the best method, right?
Yeah, this is the best method.
Okay.
Why it is the best method? You know, the product and the byproduct which have been formed. Like product which we expected that we get in this method, right? But then
Yes.
apart from that, you get a byproduct and that byproduct would be in a gaseous state. So you need not to use any other separation method to remove it. Correct?
Okay. Yes.
And hence it is the best method. See what is given here. Thionyl chloride react with the straight chain primary alcohols to give unarranged alkyl chloride. So here also rearrangement does not occur. Okay. The
Yes.
byproduct obtained are gases. See, there are no need to put extra efforts for its separation. And therefore, this method is preferred for preparation of alkyl chlorides.
Ma'am, so we
Okay.
always want it in gas form only.
Not exactly. Sometimes like it depends. Thionyl chloride, if it is readily available, if it is cheap, then only we can use, right? But then
Yeah.
if another reagent is easily available, or thionyl chloride is not easily available, you have to demand it from foreign, like many things would be there. Depends on situation, you have to use a reagents. So these
Okay.
X, Y, Z, 3, for cooking any food, you have 3 recipes, but then which one is best for your situation currently, that only you opt for, right?
Yes,
The
ma'am.
same thing is for the reaction as well. So different methods would be available. This is the best why, because whatever byproduct would be like generated, that would be in a gaseous state. So you need not to like put any extra efforts to remove them. It will be automatically go into environment, correct? And
Yes,
that
ma'am.
byproduct would be, I guess, sulfur dioxide, I guess. We will check it. First of all, we are going to see with PCl3, then PCl5, and later thionyl chloride SOCl3. And I guess that part already I told you, thio compound means sulfur compound and azo compound means nitrogen.
Nitrogen. Yes.
Yeah, that you keep in a mind. Now what they said about when ethyl alcohol is reflux means heated with a phosphorus trichloride, ethyl chloride is formed. CH3CH2OH treated with PCl3. You will get what? One chlorine will go over here, OH would be removed, it will form H3PO3. That is phosphorus acid. Phosphoric means H3PO4, right? So it is
Yes.
phosphorus, not phosphoric. Okay?
Okay.
Yeah. Next one is what? See, here, when ethyl alcohol is refluxed with phosphorus pentachloride, ethyl chloride has been formed. Same product would be there because your substrate is same. Only the byproduct would change. Obviously, it is phosphoryl chloride, POCl3, and HCl, hydrochloric acid would be generated because 2 chlorine would be extra in this case.
Okay.
Correct?
Yeah.
Yeah. So one is gone with the compound. Okay. 3 would be here in a phosphoryl chloride. Yeah. Yes. And 1 would be here in a HCl. So 1, 3, 4, and 1 more is 5. Clear?
Yes, ma'am.
Get balance. Now, next one is what? It is important one, thionyl chloride. When ethyl alcohol is refluxed with a thionyl chloride in the presence of pyridine. Pyridine is what? It's an organic base. Keep it in your mind. What is a pyridine?
Organic.
Base. Okay? Ethyl chloride is formed. The byproduct obtained are gases. Therefore, this method is preferred for the preparation of alkyl chloride. Because CH3CH2OH ethyl alcohol treated with SOCl2 in the presence of pyridine and reflux, you will get CH3CH2Cl. Means OH would be
reflux is heat.
Heat. Boil together in short.
Okay.
Okay. OH has been replaced with what? Cl. You will get another product is what? Here SO2, sulfur, oxygen. This oxygen would come over here. SO2 and H and Cl would form HCl. Correct?
Oh, okay. Yes.
Position of this would be SO2, and obviously you need to show it with the upward arrow as it is in gaseous state.
Yes.
Even the HCl is also in a gaseous state.
Yes.
Yeah. Clear? Any doubt? Have you noted these reactions or not?
Yes, ma'am. Ma'am, do we remember these reactions?
You have to, obviously, because they may ask you about name reactions. They may ask you the this one, role of reagent. What is the role of this
only
reagent?
these reactions we have to remember, right?
Yeah, these reactions, what happens in this reaction, what is the reactivity site, that all things will be need to be keep it in your mind. And you will very what we can say precisely you can detect it when you will be in a practice always. Because chemistry is a volatile in nature. If you're not revise it regularly, it will be completely moved from your brain.
Yes, ma'am.
Understand? So you need to revise it again and again.
Yeah, ma'am, got it.
Now, next part is what? From hydrocarbon. How to prepare ethyl, not ethyl, alkyl halide from the hydrocarbon. Hydrocarbon means alkane. Okay? Correct?
Okay. Yes.
So this is, I guess, a photochemical reaction. Okay? So alkyl halides are formed from the saturated as well as unsaturated hydrocarbons.
Yeah.
Saturated means which consists carbon-carbon single bond. Unsaturated means either carbon-carbon double bond or carbon-carbon triple bond.
Yes.
Okay. Now halogenation. First thing, if you do the halogenation for hydrocarbon or alkane, what happen? You will get the alkyl halide. A reaction of alkane with halogen. Halogen means chlorine, bromine, and iodine. Why I have written here Cl2, Br2, and I2? Because these are
These are the halides.
how it will be. These are in a molecular state. Diatomic molecule.
Okay.
These molecules are not single atomic, these are diatomic, and hence we should write it Cl2, Br2, I2. Single Cl, single Br, single I, you are not able to see it. Okay? Unless it does not in a compound form. Okay.
Yes.
In the presence of appropriate condition forming
Ma'am,
a alkyl halide. Yes.
we don't use fluorine.
Fluorine is a highly electronegative halogen. Okay. And because of that, it's highly reactive and corrosive in nature. And because of that, we avoid using it in a halogenation directly.
Okay, ma'am.
Yeah. So that is also like mentioned below. You will come to know why. Okay.
Oh, yes.
And polyhalogen. Right. So
Yes.
what happened about the methane has been taken in excess manner. Okay. Ultraviolet light is there. When ultraviolet light would be there, one of the hydrogen from here and Cl from here would be form HCl, and another Cl would be go and take a place of hydrogen. So you will get CH3, one hydrogen gone, and Cl would come at this place. Okay.
Okay. Ma'am, but why is it forming HCl?
HCl.
Yeah,
Why?
ma'am.
That's what I told you, na. See, this is what CH4. I'll let you know here. H, 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 H. This is CH4, correct?
Yes, ma'am.
Cl2 means Cl and Cl, correct?
Yeah.
So this hydrogen and Cl would be from HCl, correct? And this Cl come at the place of it. You will get C, H, 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 and here it will be what Cl, correct? And plus HCl, correct?
Yes.
That's it. So this is a reaction, and another reaction would be what I'll let you know. When excess of chlorine is used, means instead of the CH4, obviously it is in excess quantity. If there would be Cl2 in excess, what happened? When excess chlorine is used, tetrachloromethane, a major product, is obtained. Means what happened? When there is a chlorine and CH4 in excess manner, so each and every chlorine molecule would form one HCl, okay? And one of the chlorine from Cl2 would be replaced the one hydrogen from methane, correct? Same thing is happening. If suppose one more Cl2 I have added over here. So what happened? This hydrogen and chlorine would be gone as a HCl, and this chlorine will come at this place, correct?
Yes, ma'am.
Again, one more chlorine if I have added, what happened? It will form this HCl and this chlorine will come at this place. So same thing is happened for all the hydrogens, right? And you will get tetrachloroderivative of methane, that is CCl4 is a major product. All chlorine has been, all hydrogen has been replaced with chlorine. And if you go sequentially, here will be the first chlorine, one chlorine, then the two chlorine, then the three chlorine, and at last four chlorines would be there in the product. Name is methyl chloride, methylene dichloride, chloroform, and carbon tetrachloride. Okay?
Okay, ma'am. Got it.
In this manner. So please note down this reaction. It is important. You have learned it in your earlier age, in your previous grades as well. But then this would be a photochemical reaction. I don't know whether somebody explained you about it or not.
No, ma'am. We had it, I think, in 10th grade.
I guess, maybe. So once you have done, let me know so I can proceed with the content.
Yes, ma'am. Just a second. Done, ma'am.
Fine. Just a minute, okay?
Yes.
Yeah. Iodination and fluorination. See the question you asked about it, it's written. About iodination, what's given? Like iodination is a reversible reaction, right?
Yes.
You would see this arrow. Yeah. So however, iodination reaction is a reversible reaction. HI being a strongest reducing agent, it reduces methyl iodide back to methane. Because what happened when iodination is happened, your byproduct is what? Hydrogen from here and iodine from here, it will form HI. This is what? Strong reducing agent, correct?
Yes, ma'am.
Yeah. So what it does, it reduces your this methyl iodide back into your methane, right? And reduction means gain of hydrogen, loss of oxygen. So
Yes.
CH3I will gain hydrogen again and come back into its original state as a CH4.
Yeah,
Okay?
got it.
And because of that, it is reducing. Now next is fluorination. About the fluorination, what they said, a reaction of alkane with fluorine is explosive, and also hydrofluoric acid is a poisonous and corrosive. Hence, alkyl fluorides are not prepared by the halogenation of alkane. Got it?
Yes.
The same answer I gave you?
Yeah.
Yeah. If you want to note down, you can. It's up to you. Are you going to write down at least for iodination?
Yeah, ma'am, I'll write down
So
fluorination.
one thing, just write down the reaction, and
Okay.
about it, you write down this HI is strong reducing agent. Because of that, reaction is reversible. Okay?
Yes, ma'am.
Yeah. Now this we are going to see. I guess Markovnikov and anti-Markovnikov rule or Sedzev rule we have to see. If you have done, let me know.
Yes, ma'am. 1 second. Done, ma'am.
In just a minute.
Yeah.
Now see, we are going to see the bromination of propane, right? Bromination of N-butane and the bromination of 2-methyl propane. Okay. See what is given here and why these all products have been formed, that we have to check. So
Okay.
bromination of propane they have done. Propane is here. CH3, CH2, CH3, correct? Yeah.
Yeah.
Now Cr2 in ultraviolet light, it will like remove this one of the hydrogen from primary position and even from the secondary position. Two hydrogens are only available in this compound, right? Because this is a primary, this is also primary. So these two hydrogen, these three hydrogen and these three hydrogen are the primary hydrogens, and these two hydrogens are the secondary hydrogens in this compound, correct?
Yes, ma'am.
Yeah. So either this Br will take a hydrogen from primary carbon or from the secondary carbon. When it is taking from the primary, you will get the compound 1-bromopropane, right? It becomes CH2Br. CH3, CH2, CH2Br, correct?
Yes, ma'am.
HBr would be side product. And at the same time, if this Br goes at the secondary position, you will get the compound CH3, CH3, and CH3CH will be attached with the bromine, right? So it will be 1-bromopropane, and this will be 2-bromopropane. And if you see product yield, it will be 3% and it will be 97%. Why this is so? Because secondary carbocation would be more stable as compared to primary. Understanding? Yes?
Ma'am, this one I didn't understand. Can you please explain again?
Okay, sure, I will. Not an issue. I just wanted to tell you, we have learn about the primary and secondary carbocation.
Yes, ma'am.
Yeah. So what happened if one of the hydrogen would leave from here? It will generate the carbocation like this CH3, CH2, CH2 plus, correct?
Yeah.
And if secondary carbon would lose, then it will generate CH3, CH, CH3, correct? With positive charge over here.
Yes, ma'am.
If your Br would come here, you will get this. And if your Br would come here, you will get this. Correct?
Okay. Yeah.
Right. So this is primary and this is secondary. 1-bromopropane, this is 2-bromopropane.
Okay.
1, 2, 3. And it is what? 1, 2, 3. Correct?
Yes, ma'am.
Yeah. Now what happened in this case? What happened in this case? Your secondary is more stable as
Yes,
compared
ma'am.
to primary, and hence as it is more stable, bromine will occupy the secondary position more often as compared to primary, because primary is less stable and immediately it undergo rearrangement.
Yes,
Hence
ma'am. Got it.
that would be 3% with 1-bromopropane and 2-bromopropane is a 97%. Got it?
Yes, ma'am. Understood.
That's it. Now next one would be what? Bromination of N-butane. Now butane 1, 2, 3, 4. right? Same, like instead of propane, you are going to take a butane, same primary, and then the secondary, correct? One bromobutane, two bromobutane. Primary and secondary. There here are also two kind of hydrogens only. These are the primary one. See, this CH3 is the primary group, and this CH2 group is secondary group, correct?
Yeah.
Yeah. So if these hydrogen gone, you will get the first product. If this hydrogen gone secondary, you will get the second product.
Ma'am,
Okay.
so the first one is for primary and the second one is for secondary.
Yes, got it.
Yeah.
And hence, because of that, you will get the second product as 98%, and the first one is just 2%. Primary is unstable. So
Ma'am, so we get either this product or either that product.
that product. But then percentage matters, which one is major and which one is minor, you should decide.
Okay, ma'am. Understood.
Yeah. Now, next is bromination of 2-methyl propane. In this case, there is a tertiary carbocation would form. So maximum product, secondary also, primary would form and secondary would form. If primary would be there, then this CSC would lose its hydrogen, correct? And you will get your first product. It is in trace quantities, check, very trace amount, okay?
Okay.
And if this hydrogen would be lost, you will get the bromine at the center, means with the tertiary carbon, and it's a maximum around 99%.
Okay, ma'am.
Got it? Because tertiary carbocation is more stable as compared to primary.
Yeah, so that's why it's 99%.
Yes, yes. Primary is less stable than the secondary, and second is less stable than the tertiary.
Okay, ma'am.
Carbocation, stability. Okay, if you want to write down, write it. So on the basis of that, you can like identify which one is a major and which one is minor. Clear?
Yes, ma'am. 1 second. Done, ma'am.
Yeah. Now we are going to see the disadvantage of halogenation of alkanes for the preparation of alkyl halides, what it is. Direct fluorination of alkane is highly exothermic, explosive, and invariably leads to the polyfluorination, and hence decomposition of alkanes happens. It is difficult to control the reaction, and hence it does not, like what we can say, we are not go for, or we are not opt for the fluorination of alkane. Not halogenation, but then fluorination of alkane. Direct iodination of alkane is highly reversible and difficult to carry out, because whatever product you will get, again it will be come back into its original state. Okay. And
Yes.
in direct fluorination and the bromination, the reaction is not selective. It can lead to the different isomeric monohalogenated alkanes or alkyl halides, as well as polyhalogenated alkanes. Just now we have seen about the methane. It may give you methyl chloride, methylene dichloride, chloroform, or methyl tetrachloride, methyl tetrachloride, okay?
Yes.
Okay. So these are several products you will get. Reaction won't be selective if you use directly, right? So this is disadvantage. Okay. So why direct iodination of alkane is not possible? Already we have seen it's a reversible reaction. So
Yeah.
so it's no need, right?
Yeah, ma'am. No.
So whatever products we have formed, like I have explained you about the stability of secondary carbocation. But then at the same time, there is one rule which you have to learn, and on the basis of that, you can decide the major and minor product. Okay. So what this Markovnikov rule says, when an unsymmetrical reagent is added to an unsymmetrical alkene, what it is? Alkene, not alkane. Okay. When unsymmetrical reagent is added to an unsymmetrical alkene, the negative part of reagent get attached to that carbon atom of a double bond, which carries, it should be a printing error, carries less number of hydrogen atom, means mostly it goes to the secondary or tertiary carbon, right? So secondary carbon and tertiary carbon are the carbon which carries less number of hydrogen as compared to primary, correct?
Yes, ma'am.
Yeah. So what they said, this is your unsymmetrical reagent. This is unsymmetrical alkene. When these two react with each other, what is the negative part? Hydrogen is a positive, hydrogen is a negative.
Yeah.
So it will go to the carbon which is attached to the less number of hydrogen. More number of hydrogen it won't go. If it is go to the more number of hydrogen, it will be minor product. Check. And if it go to the less number of like carbon, carbon which
When it
consists
goes to secondary and tertiary, it will be major.
yes.
Okay.
Understood?
Yeah.
This is a Markovnikov rule. Please write it down, this rule, and after that I'll explain you its opposite rule that is called as Kharash-Mayo effect, and another name is for the peroxide effect, and even it is also called as anti-Markovnikov rule.
Okay.
Okay? Please note down this with example. This is important. Done?
1 second. Yes, ma'am.
Okay. Now see the next one, Kharash-Mayo effect. What happens in this same example they have given? So a Kharash-Mayo effect is also called as the peroxide effect. In this case, what they said, the addition of HBr to the unsymmetrical alkene, propene, in the presence of benzoyl peroxide. Either you can use benzoyl peroxide, normal peroxide H2O2 is also okay. Okay. Takes place in opposite orientation. It will take place in presence of this benzoyl peroxide or hydrogen peroxide in opposite orientation to that of Markovnikov rule. And hence, this is known as the Kharash-Mayo effect, peroxide effect, or anti-Markovnikov addition. Okay, means according to Markovnikov, what your negative part would go to the carbon which consists less number of hydrogen, right? But then if in your reactant peroxide is present, benzoyl peroxide or peroxide H2O2, among these two any, okay. So what happened? This Br would prefer to go at the carbon which consists the large number of hydrogen, and your primary or 1-bromopropane would be the major product.
Ma'am, if the reactant has what in it?
Benzoyl peroxide or hydrogen peroxide.
Okay.
H2O2, water is what? H2O. This is hydrogen oxide, right?
Yes,
And
ma'am.
H2O2, hydrogen peroxide, means for each hydrogen, one oxygen, like that. Okay.
Yes,
and
ma'am.
H5CO twice, and O2 is oxygen is also twice. Benzoyl peroxide, 2 to both. Okay.
Yes, ma'am.
Yeah. So write down this formula. This is benzoyl peroxide, H2O2, hydrogen peroxide. Write down their names. Okay. Later you should not forget.
Yes,
Yeah.
ma'am. I'll just write it 1 second.
Yeah. So this already we have gone through, I guess, first one. For the second, write down the answer. Let me see whether you are able to write or not.
Yes, ma'am. The major will be
Go
when.
for the both, 1 and 2. In first, see, H2O2 is not given, like peroxide is not given, right? But then in second, peroxide is given. So like, let me see what answer you will write for. In first, peroxide is not there.
Yeah, in the first answer, when Br attaches to the second carbon,
Yeah.
is the major, and when it attaches to the third carbon, it will be the minor.
Okay, means here about CH3, CH2, CH2, Br would be minor, correct? This is minor.
Yes, ma'am.
And this is major, correct?
Yes,
Good. What about this?
Ma'am, it attaches to the first carbon.
Are you sure?
The more number of hydrogens, right?
I won't think so. First one,
Ma'am, the last one.
yes, correct. CH3 twice, C, okay, single bond. Okay, here it will be C, H2 or Br2. CH, Br, CH3, correct?
Yes.
And one more hydrogen should be over here to like balance the valencies.
Yes.
This would be major or minor?
Major.
Minor, better.
Okay, yeah, the least number. Yeah.
Yeah, and if on this, like, no, correct. This hydrogen gone, no? This?
Yeah, ma'am.
Yeah, so this will be major. And if it would go here, that would be minor.
Yeah.
Correct? Answer would be given. I'll check and I'll let you know. Just a minute. One more is here. This already we have seen. First one, just opposite product would be there. First reaction, whatever we have seen, its opposite product would be occur due to peroxide effect. Okay.
Okay.
Yeah. So here is the answers. Check. Yeah. See, in this, if it is attached to the carbon which consists less number of hydrogen is a major product, and to the hydrogen which consists less number of more number of hydrogen is a minor product. When there is a peroxide, you can check. Here,
Yes.
if it will be major.
Yeah.
Right? And if it will be at this point, it will be minor.
Yes, ma'am.
Correct?
Ma'am, the third one?
And the third one is given here below. Opposite to the first one, completely.
Okay.
Major and this is minor. Take a snap of it and rewrite it again in your notebook so it will give you more clarity.
Yeah.
Yeah? I think time is up. Correct?
Yes, ma'am.
Because I have any other class as well, so otherwise I would continue.
Yes.
Yeah, fine. Shall I end the class now?
Yes, ma'am. Thank you.
So we will meet again at the same time again, 5:30 tomorrow.
Tomorrow.
Yeah.
Okay. Thank you.
Okay, beta, bye.
Bye, ma'am. Thank you.